ओके, हम लोग देखते हैं पार्टीशन एंड इक्विवेलेंट क्लास क्या होता है। राइट। ओके। सबसे पहले देखते हैं पार्टीशन क्या होता है। यू नो व्हाट इज इक्विवेलेंस रिलेशन? ओके। यस। तो क्या होता है? रिफ्लेक्सिव, सिमेट्रिक एंड ट्रांजिटिव। राइट। उसको बोलते हैं इक्विवेलेंस रिलेशन। ओके। सपोज यू आर गिवन व्हाट? So this is a question, right? Show that this is one question. So that the relation R on set of all integer defined by x related to y if and only if mod x minus y less than 1 is not an equivalence relation. Okay, let's see. The question is what? You have to prove that what the relation R on set of all integers, right? Defined by if and only if mod x minus y is less than or equal to 1 is not an equivalence relation. So for proving equivalence relation, you must have to prove what? First, you have to check whether this is reflexive or not. So for reflexive, what condition must be there? X is related with X. So Y is replaced by X, right? X minus X is 0. And this is 2. 0 is less than 1, right? Yes. It means reflexive property holds. Okay. Now we will see what? Symmetric, right? See, symmetric property. What is symmetric? If X is related with Y, then Y is related with X. Okay. So replace Y by X. And you know this is what? Take minus common. And you know plus minus is always positive, right? This is also what? True, right? Symmetric property holds. Understood? Now we will, yes, because inside mod you can take negative or positive, it is always positive. This is absolute value. Absolute value means whatever the sign inside the bracket, you will get positive only. Now we will prove for transitive. We will try to check whether this is transitive or not. First write up to here. Noted? Okay, written. Transitive. X is related y means what? Mod x minus y is less than 1. Right? Understood? Y is related with Z means what? Y minus Z is less than or equal to 1. Okay? Yes. You have to prove what? X minus Z less than or equal to 1, right? Let's suppose X minus Z less than 1. So insert, can I write above? See, let's suppose X minus Z is less than 1. Introduce Y inside the bracket. Right? You can write, yes, yes. Because minus Y plus Y becomes cancel. Right? Make it pair. Understood? Yes. So you know A plus B is less than or equal to mod A plus mod B, right? So you can write what? Right? Yes. But X minus Y is what? 1 and Y minus Z is 1, right? 2 is greater than R is equal to 1. This is true or false? Not possible, right? Na false. It means you can say R is not transitive, right? If any one of the property does not hold, then you can say what? Yes. You can say R is not an equivalence relation. Okay. This is called inequality property. Triangle inequality. Okay. Mod x y it is already given. Less than or equal to 1. If option have given 1, then you can write here 1. Okay, because maximum value is 1. So you put there maximum value. Understood? Yes. One more question is there. Second question is what? See this. So that the relation on all integer if and only if x minus y is not. Okay. This is very important question. See. Show that the relation are defined on set of all integers if and only if This is called if and only if. Okay. M belongs to positive integer and M is also greater than 1 is an equivalence relation. Yes. This is not equal to, this is called congruent. Okay. First, I tell you what is the significance of this. So, whenever x congruent y mod m is given, it means what? X minus y is divisible by m. Okay. Understood? Yes. Yes. But what, how will you read? You will say x congruent y mod m. You can read like this, but its meaning is what? X minus y is divisible by m. Okay. Here one. No, no, no. Because divisor is also always given. By what? If one is divisor, then you cannot write because one divides every number. Here it is strictly saying m is greater than 1. Cannot be 1, right? Yes. It can be any positive number, but it is greater than 1. Not negative also. Okay. So you have to prove what? This is an equivalence relation. So for equivalence, what you have to prove? Reflexive relation. What is reflexive relation? Okay, x minus y is divisible by m can also be written as x minus y is equal to m of k. K is an integer, right? Na? Because multiple of m, right? Yes. So for reflexive relation, what you can write? X is related with x. So x minus x is what? 0. And 0 is divisible by every number, right? This is true. Symmetric, right? What is symmetric? If x is related y, then y is related with x. It means what? If x minus y is divisible by m, it means what? X minus y can be written as what? M of k. Then y minus x can also be written as what? Take minus common, you can write minus xy. So minus minus nk, right? So y minus x can be written as what? M minus k. K is what? Any integer. So you can say y minus x is divisible by is also divisible by m, right? Na? Because y minus x comes in factor of m. How? Let's suppose x minus y is 25. 25 is divided by 5. Then y minus x will be what? Minus 25. Minus 25 is also divisible by m. 2, right? Right? Let's suppose x minus y is equal to 5. It divisible by 5. Then y minus x will be what? Minus 5. It is also divisible by 5. Yes. It means whenever you are swapping x with y, y with x, it is also divisible by m. Okay. R is symmetric. Now I will tell you transitive. First write up to here. Write properly because in your solution book, they are not clearly written. They just say this is reflexive, symmetric, and transitive. Okay, now I will prove mm, transitive relation. See, x minus y is divisible by m. You can write what? M of multiple of k, right? Let's suppose k1. What is k1? K1 is any integer. Y minus z is divisible by m. Y minus z is mk2, right? K2 is also integer. Then suppose you are adding those terms. Mk1 plus mk2, right? Minus y plus y cancel. Okay. Take m common from right hand side. Sum of two integer. Sum of two integer is what? It is also an integer. Let's suppose this is k. So k belongs to z. You can write what? So x minus z also comes in this form, right? Yes. By using this, you can say what? X minus z is divisible by m, right? By property, you can say what? X minus y, x comma y is y, y comma z is r. Then you can say what? R is transitive relation. Uh, in which case, what you are saying? Mm, you can prove by only taking example, particular number, right? But you have to prove in general form. That's why you have to prove like this. No other way. Okay. Therefore, R is an equivalence relation. Why equivalence relation? Yes. Okay. Yes. इतना जल्दी एवरेज कैसे हो गई एवरेज कब करेगी मैं आ गया 9:30 कितने दिन से नहीं आया कल नहीं आया तक परसों नहीं ठीक है परसों भी नहीं आ रहा मंडे वही परसों तो संडे आया था मंडे मंडे ट्यूसडे नहीं कल और परसों नहीं नहीं कल परसों तो आया था मैं सुबह चला गया था ठीक है हो जाएगा हाँ भाई हो सकता है परसों में आया था मुझे आया था कल नहीं आया था तो लड़की को बुलाया है हाँ आ रहा हूँ टीचर को कैसे वो आएगी सर 11:30 बजे 11:30 बजे टाइम रेडी करके रखता हूँ Done? Okay. Now we will see equivalence class. What is equivalent class? Anything? What you know? Yes, yes. See, let's suppose R is a relation. R is what? Be an equivalent relation. Okay. I tell you what is equivalent class. So R is what? Equivalence relation. Equivalence means what? It satisfies all three properties and such that A belongs to R, then the equivalent class of D with respect to R is the set of all elements in A. Okay. I tell you, those are related to A. Through R. So this is representation of equivalence class R such that B belongs to A. This is A, B belongs to R. Okay. Yes. This is B actually. Okay. Yes. If if okay. Okay. If B, if class B belongs to class A, then you can say what? Class of B and class of A must be equal. Okay. Yes. I tell you how to write this. Right? So you can say equivalent class is a set of elements that are related to each other under an equivalence relation. Okay. In simple way, you can write what? A set of elements that all are related to each other under an equivalence relation. So equivalence relation is what? A relation on set is an equivalence if it satisfies reflexive, symmetric, transitive, right? Suppose you want to create a equivalence class of an element with same remainder when divided by 3. Right? For example, you can write here, take integer with the relation. What is the relation? Same remainder. When divided by 3. You know when any number is divided by 3, gives remainder what? Either 0 or 1 or 2, right now? Yes. Tell me what are the number when divided by 3 gives remainder 0? Remainder 0. 0 means what? Perfectly divisible by 3. So these are the number whose remainder is 0. This is called 0 class. 1 class is what? What are the numbers when divided by 3 gives remainder 1? 1, 4, 7, 10, right? And negative direction is -2 and so on, right? What are the numbers when divided by 3 gives remainder 2? 2, 5, 8, right? 11 and so on. In negative direction, -1 and so on. So these three classes, partition, integer, every integer belongs to exactly one class, right? Yes. So there are three classes. They are equivalent class. Why? Because 0, 3, 6, 9 belongs to 0 class. This is called one class. Never write parenthesis in parenthesis. Always use square boxes. Okay? Yes.
ये आप बोर्ड में लिखा, इसमें लिखा, वो उधर का हो गया ना। और ये सॉफ्टवेयर आपका जूम
रिकॉर्ड भी हो रहा
है।
है। रिकॉर्ड भी हो रहा है।
हाँ क्या,
तो
मतलब स्टोर होता है वीडियो।
ये सेव हो जाएगा, उसके बाद को देख सकते हैं बाद में।
और ये लिखा है आपने, ये पूरा हैंड राइटिंग इसमें ये लिखा है।
हाँ।
तो वो डिफरेंशिएशन का मैं कॉन्सेप्ट क्या, बेसिक्स एक आध घंटा 2 घंटा सिखाइए बस। उसके बाद मैं पार्टी का शाम पूरा अवेयर एक्सेस किया।
आज है क्या फिर?
फिर
आज आज करते हैं।
आज की तो होते हैं।
2 बजे के बाद फिर चले जाएंगे।
हाँ नहीं नहीं ठीक है, चलो ठीक है।
डन। डन। ओके। लेट ए इज इक्वल टू 1 2 3 4 5 6. Okay. And R with the relation congruent modulo 2. You know what is congruent modulo 2? X comma y such that x congruent y mod 2. Right? It means when any number is divided by 2 gives remainder y. Okay? Yes. So what are the number when divided by 2? You know x congruent y mod 2 is what? It means x minus y is divisible by 2, right? So find those pair which satisfied this condition. Yes. First find the relation R such that x minus y is divisible by 2. So 1 comma 1, because 1 minus 1 is 0, 0 is divisible by 2. 1 comma 3, you cannot take 1 comma 2. 1 comma 2 is what? Their difference is minus 1. So minus 1 is not divisible by 2, right? 1 comma 5, right? Now 2 comma 2, 2 comma 4, 2 comma 6, 3 comma 3, 3 comma 1, 3 comma 3, 3 comma 5, right? Then 4 comma 2, 4 comma 4, 4 comma 6, 5 1, 5 3, 5, 5, 6, 2. This is what? An equivalence relation, right? Yes. So R is an equivalence relation. But you have to find what? Equivalence class, right? So what will be the class? Congruent modulo 2. So when any number is divisible by 2, its remainder is either 0 or 1. Right? So what are the number when divisible by 2 gives remainder 0? 1, 1, 1. Remainder 0 will give what? Sorry, 2, 4, 6. Understood? Because 2 is completely divisible by 2. No remainder, no remainder means 0 remainder. 4 is divisible by 2 perfectly, right? So 0 will be remainder. 6 is also divisible by 2 completely. 0 means what? Those number when divided by 2 gives remainder 0. Or you can say what are the number when completely divisible by 2. When any number is completely divisible by 2, then remainder will be 0, right? Yes. Yes. What are, yeah, yes, because you have finite set. So out of these, only three numbers are there whose remainder is 0 when divided by 2. So out of these number, how many numbers are there when divided by 2 gives remainder 1? You know 1, 3 and 5, right? Because when 3 is divided by 2 gives remainder 1. Okay? Yes. If I ask you what is the equivalence class of 2, what are the number when divided by 2 gives remainder 2? So 2 include in this, right? Right? See, it is equal to 0 class. Okay? 4 class, 6 class. Understood? Yes. Understood? Yes. Understood? Equivalence class has one important property. If you take the union of class, you will always get original set A. Okay? Union of equivalent classes gives same set. Okay? And if you take intersection, you will always get 5. No common elements. See, when any number is divided by m, is remainder will always 0 to m minus 1. if you are divided by 2, then remainder will be either 0 or 1. Remainder 0 means what? Perfectly divisible. So what are the number which are perfectly divisible by 2? You know it will be 2, 4, 6, right? Yes. Yes, that is enough. Right? Note down this. Yes. How many unique classes are there? So only 2 unique classes will be there for modulo 2. For a modulo 3, you will have 3 classes. 0, 1 and 2. Okay. For modulo 4, you will have 4 classes. Understood? Yes. Similarly, for 5 will be 5 unique classes will be there. Yes, from 0 to 4. Yes. Done? अब जैसे ये क्वेश्चन देखो. Can you try this? इसका इक्विवेलेंट क्लास बताओ. Square of x is equal to square of y, right? So what numbers are there whose squares will be same? Yes. So only one number is there, right? In zero equivalent class. In one equivalent class, 1 and minus 1 both number are there, right? For two number of class, here two elements are there, right? It means that it is also minus 1 equivalent class, right? Understood? Whatever the number of elements, whatever elements are there in there, then you can also write the corresponding element for equivalent class. Okay. Yes. For 3, and so on. So in general, what you can write? A and minus A. Right? Yes. So in general, you can write what? A and minus A. What is A? For all A belongs to any integer, such that A square minus A square. Right? Understood? What? No. Yes, it can be 0 because 0 is a whole number, right? So 0 is a whole number. It means you can write minus 0 plus 0. It doesn't matter. So for 0, it is also whole. अभी नहीं है. Done. Okay. Partition of set. Suppose a set A is there, you divide set into many parts, right? Such that A1 union A2 union A3 union AN each A, right? And A1 intersection A2 intersection A3 intersection each 5. In general, you can write what? U, I, 1 to N. You can write in this form, okay? Intersection I into N, AI is equal to 5. This is called partition of set. Okay? This is set A. Divide set into two parts such that like this, okay? A1, A2, A3, and so on, right? For example, 1, 2, 3, and so on. Let's suppose A1 is equal to 1, 2, A2 is equal to 1, 2, 3, A3 is equal to 4, 5, and so on, right? A1 union A2 union A3 is what? Let's suppose AN is what? A A1 union intersection A3 is what? Not 5 because 2 is common in A1 and A2, right? So this is not a partition set. Okay. What is partition set? If none of them is common. One, two, three, four, five. So what are the union? A, right? Intersection 5. Yes. So this is what partition of set. Okay. So you divided set into three parts. One is 1, 2, 3, 4, and 5, right? Yes. This is partition of set. Understood? Yes. See this. A set is divided into three parts. Tell me this is partition or not. Take union of this. What will you get? A. Take intersection. What will you get? So this satisfied both condition. This is partition. Take union of this. A, right? What is the intersection? This is also a partition. Take union. A, right? What is the partition? 5. So all are partition of sets. Understood? So in many way you can write in any way. Right? Okay, see. Every partition of A have an equivalence relation. This is very important. It means that you divided this set into two parts or three parts. All parts are equivalent relation. Okay. And correspond to each, there is unique partition. Reverse, you can say. If unique partition is there, then equivalence relation, or you can say if equivalence relation there, then you can say unique partition. This is very important. You can note this. I tell you what is this. Uh, if it is unique partition, right? Then you can say unique equivalence relation. If equivalence relation is there, then it will be unique partition. First write this, I tell you. Okay. A is equal to 1, 2, 3, 4. You divided set into three parts, right? You know the relation is what? 1, 1, 2, 2, 3, 3, right? Right. Yes. Uh, for 1, 1, you will have only one pair. Yeah. For 2, 3, you will have four pair, right? Right? No, no. See, this is first pair. How many relation will be there? 1 comma 1 only. Right. You have only two sets, sorry, two elements. So how many pair you will form? 2, 2, 2, 3, 3, 2, and 3, 3, right? Yes. You have only one pair, 4, 4. When you combine all these pair, it becomes a equivalence relation. Very important. This is an equivalence relation. Okay. Equivalence relation means what? It holds reflexive, symmetric, and transitive property. Right? So for every equivalence class, whatever the relation forms, it will be equivalence relation. Understood? You can check for this also. You have three pairs. Three pair means 1 1, 1 2, 1 3, 2 1, 2 2, 2 3, 3 1, 3 2, 3 3, and 4 4. Right? So this is also an equivalence relation because it also satisfied all the equivalence properties. Hmm. Yes, first find partition set and make a relation. Whatever the relation will be formed, it will be equivalence relation. What? हाँ. Right? Now see this question. equivalence relation x congruent y mod 2. So what you have to find? 1 and 2 plus. Okay. Yes. You know, class 1 is what? When divided by 2. So all the elements which gives remainder 1, right? 2. 2 is similar to y, 0, right? Yes. Yes, yes, sir. Correct. So you will get what? 135, right? And this is 0 means what? 246. That's it. Right? So 1 equal to 3 equal to 5. Right? 2 to 4 equal to 6. Right? Right. When you take union of these two, you will get what? 1, 3, 5, 2, 4, 6. You are getting what? Same thing? Yes. So this is what? Partition offset. Understood? Yes. ओके। राइट ना। अब जनरल क्वेश्चन क्या है कि अगर ऐसा कुछ क्वेश्चन आ रहा है तो व्हाट इज एम, एम इज एनी इंटीजर, तो रिमाइंडर क्या क्या हो सकता है? 0 1 2 से लेकर m-1 तक। तो सबका यूनियन लेंगे क्या आएगा? जेड आएगा ना। और इंटरसेक्शन में पाई आएगा। इसका मतलब ये भी क्या इक्विवेलेंस क्लास बन सकता है। राइट, तो ये इसका जनरल डेफिनेशन है, ये भी नोट कर लो। हाँ, पार्टीशन होने के लिए। तो ये तो फिनिश हो गया, राइट। अभी नौ। चैप्टर नंबर। एट चैप्टर। यस। ना ना, हाँ यस, एट चैप्टर। 519। ओके। हम्म। Take this question. Question number two. Yes. See, A comma B is such that A and B are of same age, right? So tell me whether they are equivalent or not. So is it reflexive? Same age. Yes. Okay. Yes. Second one. Hmm. This is also equivalent. Hmm. Hmm. A and B are share a common parent. Common parent, let's suppose A and B are brothers, right? B and C. Yes, it is also the equivalence relation, right? The A and B have met. A met himself, B met himself, right? So this is reflexive. If A and B have met, then you can also say B and A have met, right? Reflex symmetric. A and B have met, B and C have met. It is not necessarily that A and C have met, right? It is not suppose you met with uh, your father. C part what? Uh, C common parents. Common parents meant what? Yes, it can be yeah, equivalence. The first is equivalence, because it satisfies all the property. This is also equivalent because same parent means what? They have same child, right? Uh, Same common parents means let's suppose A and B have common parent. Okay. Symmetric means what? B and A have common. This is also true, right? Let's check for transitivity. A and B may share one parent. B and C may share different parent. Yes, yes. Yeah. Let's suppose A and B may share one parent, right? Understood? B and C may share different parent, right? It is also true that A and C may share no parent at all. May share no parent, right? Right? So this cannot be transitive. If this is not transitive, then you can say what? No. Okay. What about D? A and B have met. It can be reflexive. Suppose you and your father met. Your father and your friend met. But it is not necessary that you and your friend met. Right now? Yes, because all are independent. So it is not necessarily that net, right? Na? So this is not transitive. This is not equivalence relation. Okay.
Yeah, the bank was the problem. The level of the water in the tank. Monitor and control the 0.5. The 1.4 and 1.1 act as an input.
Okay. A and B speak a common language. Let's suppose A and B speaks English, right? B and C speaks Hindi. Okay. It is not necessary that A and C speak same language, right? Because B is common. B can speak English and Hindi, but A speak only English and C speaks only Hindi. They are not sharing same language, right?
Zero.
Yes. Common language is what? Suppose you and your friend B speaks English, and your friend and your let's suppose other second friend speaks Hindi, right? But it is not necessarily that you and your second friend speaks same language, right? Only B is the person who speaks both. But okay, B can speak English and Hindi, right? But A and C cannot say that they speak English or Hindi perfectly, right? It's cannot share common language.
The water level is below the lower limit figure, then P 1.0 is that top. Then then P 0.5.
Yes.
Right? How procedure such that.
B and 15 and 16 are similar. I will do 15. You will show me 16. See, R is a relation of two pairs, right? Belongs to R. You have to prove that R is an equivalence relation if and only if A plus D is equal to B plus C. Okay? Okay. So for proving equivalence relation, what will you need? Reflexive. You know what is reflexive relation? This is basically what A comma B related with C comma D. Right? Yes. So for reflexive A comma B must be equal to A comma B, right? Check the condition. A plus B. D is replaced by B. A plus B. This is true. So R is reflexive. Right? Second property is symmetric. Right? For symmetric, C comma D must be belongs to A comma B, right? So here you can write what C plus D is equal to D plus A. By commutative property, you can write B plus C, A plus D, right? Similarly, A plus D equal to B plus C. Commutative property, right? So this is also true. R is symmetric. Understood? Now we will prove for transitive relation. A comma B belongs to R, right? With C comma D. It means what? A plus D is equal to B plus C, right? C comma D belongs to R. Let's suppose E comma F. Yes. So C plus F, right? E D plus E. Okay. Okay. Yes. Now add both the equation. A plus D, C plus F, right? B plus C, D plus E, right? D cancel from both sides. And what is more cancel? C cancel from both sides, right? So A plus F is equal to what? B plus E, right? You can write what? Ah, yes. A comma B is related with E comma F. And this is what you want to prove? Yes. So R is transitive. Therefore, you can say what? R is an equivalence relation. Okay, note this.